So in this video I'm going to explain solution of this Codeforces round 913 ready for division 3. So in this video I'm going to explain solution of first four problems. So now let's begin with problem number A. The name of the problem A is Rook. So what they have said, we will be given initial position of Rook on a chessboard. For example, in this case the initial position of Rook is D5 and we have to tell them what are the other possible places where my Rook can go. For example, my Rook can go on D8, D7, D6, similarly A5, B5, C5, and I have to tell them all the places where my Rook can go if the initial position is D, 5. Okay, so how to solve the problem? I think the problem is pretty much easy and implementation part only. If I tell you this implementation, here you can see. Let's suppose the initial position of my Rook is D, 5 only, which means if this is a grid and my Rook is at this position. So first of all, I will simply fix the horizontal part of the my chessboard, which means my rook can only go in horizontal direction only, which means I will only fix the you can say I will only fix the 5 part, which means I can variable change my d. So where how can my d variable? D can go from A, B, C. D is initial position, so it will never go on D again. So I will skip the D and F, G, H. Okay, so here it is one catch. But if I fix the vertical part, then my rook can only go in vertical direction only. So which means if my initial position is d comma 5, I will fix the d part and my rook can go in 1, 2, 3, 4 and 5 will not come, 6, 7 and 8. So this is the only possible answer of this case. So if I show this implementation, first of all, what I'm taking, I'm running a loop from 1 to 8. One is from number and second from character. You can see if my both the character is equal to s of 0 and my num is equal to s of 1, which means my the current position is only the that part which is given to us. Then I will simply continue. But if one of the character or the number matches with my current number, then I will simply print that character and number, or I can say initial position of that rook and simply print an endl for the next part. So this is problem number A. So now let's begin problem number B. So the name of the problem is pretty much confusing. So first of all, I will only tell you the is problem statement. So what they have said that we will be given a string. Okay. So if I show it here only, wait a minute, I will tell you here only. So suppose I will be given a string. For example, A, big A, C, B. For example, if I encounter a B, which is a small b, then I will find the lowercase in this substring, in the this substring which is the behind from the current b. So you can see what is the first lowercase letter which is behind C, which is behind this b. It is C only. So I will simply erase C, and you can see that there is no significance of single b, right? So next you can see if I am encountering another b, right? Here you can see here there is no lowercase letter before b. So I will iterate behind it. I will find the last lowercase letter which I found behind this b. So behind this b, the last lowercase letter was this a. So I will simply erase this a and the significance of this b is always null. So next you can see if I am encountering a big B. Okay, the meaning of the upper B means I will find the rightmost uppercase letter in my presenting string and erase that part. So if I erase that part, which means I've erased that a. By erasing that a, I will simply erase that b also because the you can see the significance of big B is also null. So at the end you can see my only a is left. So answer of this string would be a. So in short what they have said, if I am encountering a b, then I will find the first lowercase letter behind it and erase that part and erase that b also. If I am encountering a big B, then I will simply find the largest. Oh, I will find the rightmost uppercase letter and erase that part and erase that B also. Okay. So at then, but what will be the final string looking like? So this is the problem asking us to do. So it is a pretty much easy problem. Why so? If I tell you, for example, in this case, you can see if I'm taking this case. Okay. Mm, right. So you can see this is my sample test case one. So you can see if I'm encountering a B, I will always travels from right to left in this direction. So first of all, I will check if I will maintain a count like count small b. Initially, my count small b will be 0. Okay. Then I will come to this position. My here at this position, my count of small b become equal to 1. Then I will give at this position. I will check if it is a lowercase letter and my count of b is greater than 1. Then I will simply erase that a and decrease my count b to 0 again. Okay. Then I will again behind it behind. Here you can see I'm again encountering a lowercase letter, but you see my count b is already 0. Then I will not change. Then I will not erase it. Here you can see I'm encountering I, but my count of b is already 0. Then I will not change this I. Next I'm encountering a single small b here also. Then I will increase my small b to 1. Okay, okay. Then you can see I'm again encountering a small b. Then again I'm increase this one to 2. Okay, you can see then I'm encountering a small a. But you see my count of small b is already 2, which is greater than 1. Then I will erase that a also. Okay, so this will be the after modification of small b. Then in the case of big b, in the case of big b, you can see this is also erased, and this b and small b has no significance at all. So now what is the case of big b? So I will maintain a counter like big b and start iterating from the left to behind. Here you can see I'm encountering a big b. Then I will increase this count to 1. You can see now again going behind. I'm again encountering a big b. I will increase my initial count to +1 and it will become +2. Or you can see, then you can see if I am encountering an uppercase letter, then I will check what is my current big b, count of big b. If it is greater than 1 or greater than 0, then I will decrease it by 1 and erase that part. Similarly, if I'm going at this position, here you can see it is also uppercase letter and my big b is greater than 0 also, which is again 1. Then I will decrease it to 0 and erase that part. So after, what is my answer? My answer is all the remaining strings which are left. Here you can see my I, T and Y. Only 3 letters are left after the number of operation. Here you can see I, T, Y. So this is a pretty much greedy solution of this part. So if I show its implementation, first of all what I'm taking, I'm first of all checking the count of big B. You can see if my current letter is big B, I will simply increase the count of big B and mark it as a dot, which means I will never consider. You can see the significance of single B is always 0. And else I will check if my current letter is greater than A or it is a uppercase letter and the count B is greater than 0. Then I will simply decrease my count of B and make my current string as a dot, which means it is no significance. Similar thing I will do with small b also. And after all, if my current letter is not equal to dot, which means it has never been replaced or never been removed, then I will simply print that character and simply return. So it is a pretty much greedy solution of problem number B. Now let's begin to problem number C. So it is a pretty much tricky one problem, which I can say, and a greedy one also. So what problem said that we will be given an initial string. Okay, and what we can do, I can choose any two adjacent characters in the string which are not same and erase both of them. Okay, so if I show you this here only, so here you can see my first example is like A, B and C. So I can simply choose A comma A and erase both of these. By erasing both of these, my new string will be looking like A comma C. Now again I can remove A comma C here also. Okay, then my string length will be 0 and my answer will be empty string only. But if you can see, I cannot erase these two both A because they are both same. I can only remove two adjacent characters if they are unequal. Right. So this is a condition for removing. Now what problem asking us to do is simply I have to tell them what is the minimum possible length of string which I can get by performing some number of arbitrary options or can I say operations. Okay. So I hope so you have understood the problem. So if I tell you the position of the letter doesn't matter at all. Why so? Because you can see here, if I tell you some number of test case A, B, A, C, A. Okay. So you can see in this case whether which configuration I should take. The position of letter does not matter. If I write is like A and B comma C. Okay. You can see after any number of operation my single letter will always be left. Because you can see if my length of the current string is odd, then you can see I can logically think I can only remove two pairs at a time. Okay, so if I remove all the two pairs at a time, there should be remaining at a single element which cannot form any pair. Yes, it is right. You can see if my the length of the string initial string is low, then my answer would be always be greater than or equal to one only. It can never become zero. Okay, right. So but if my answer is but if my length is even, then my answer can be zero or cannot be zero. Okay, because you see you have understood this part that the position of the character does not matter at all. Right, this is true. So there's a pretty much good sample test case in this question, and it is this, which is A V B V C V V and D. Okay, so if I tell you the frequency of 6 is V is 6, frequency of A is 1, frequency of B is 1, and frequency of D is 1. So if I tell you what are the, you can see there's a case that I can only remove the adjacent part if they are not equal, right? Because if it's X, then my other should be Z only because they should not be equal. So if I tell you what corresponding character I should take with V so that I can remove V also and other character also, I can simply remove one single A and decrease it to 5. Okay. Again I can decrease this 5 and decrease it to 4. That means I'm making a pair like V comma VA, then a pair like V comma V. Okay. There is another D. So I can simply decrease it to 3. Okay, it is 5 only initially. The initial count of the V is 5 only. So let's skip that part only. Which means I'm able to remove this also and my remaining thing is 1 only. So tell me tell me if I'm remaining with 3 B's and a 1 D, then I will simply decrease it to 2 and decrease it to 0 also. But you can see my 2 V's are remained. I cannot make any pair with such B, which means if any point, if my frequency of letter is greater than the half of the numbers. Wait a minute, I will tell you again only. If there is a case like this, mm, yes. So if there is a case like this, if I'm having certain number of A, A, and certain number of B's like this, B, B, C, D, or either I can make it more diverse. Let here it would be a Z only, right? So you can see for every single A, I have another character present in this string. For example, I have a corresponding Z with Z. I can make this pair, I can make this pair, I can make this pair. Because okay, if I am choosing this pair, then this will be removed. Then this will be close enough. Then this will I can remove. Then A comma C will be together. Then I can remove A comma C. Then A comma D will be together. Then I can remove A comma D also. Right. So this operation I can perform. But if my number of A is greater than the n by 2, which means here you can see my length is 8 and my number of A are 4 only, which means for the every corresponding A, I have another different character present in the string also. Okay, but if you can see, if I'm having another A here and another A here, so what I can do here, I can simply erase this part because they are not equal. I can simply erase this part. Then I can simply erase this. I can simply erase this. But you can see at the end, in every configuration, I will be left with 2A always. Because you can see my length of string is 2 and my number of A are 6. Right, you are right. So you can see my number of A are 6 and number of A are 6 and number of other frequency of other characters are, you can see other characters is 4. Okay, so which means if there are 6 A's and 4 number of A, I can overlap them, but there will be remaining some part of A also, which I can never change or which I can never remove. So this will be answer in this case, which means I can never change this part also. So if I tell you again, so you can see if I'm having a certain frequency, for example, this is the frequency of A, this is the number of A, for example, and it is greater than n by 2, but whatever and my length can be any. So but this is the frequency of other characters. For example, here are the number of A, and these are the number of these are other character. I'm not saying that these are all equal, but they can be different also. So how I can map them? So I can simply map one to one. For example, in this case, I can map this one with this A, this with this A, this and this. I can map this also. But there is a segment left of A's only, which I can never map with other color. So the answer is pretty much simple. If my frequency of maximum character is greater than n by 2, okay, my frequency of other characters is greater than n by 2, then I will simply do a simple mathematical formula I will tell you. So see, if my frequency is greater than n by 2, so if this is my sequence and my number of a are these whole are my number of a, these whole are my number of a, and these are frequency of other characters. Then what I can do? I can simply, so for example, this is the frequency of maximum. So maximum frequency is the frequency of maximum. What I can do? I can simply remove the common part, which is n minus maximum frequency. Okay. Then I can simply remove the maximum frequency, and the remaining part would be the non-overlapping part, which I will be getting. For example, if these are the number of A, in this these are number of other characters, then I will overlap to my existing frequency like here, this only. Okay, but the non-overlapping case will be this only. So the formula of this can be this. Okay, you can simply drive it here only. So 2 into maximum frequency minus n. So this is the answer in this case, in which my maximum frequency is greater than n by 2. But if my none of the frequency is greater than n by 2, then what will be my answer? Okay, this is a pretty much interesting question. So what if my maximum frequency is smaller than n by 2? Then what would be answer? So you can see in this case, my every character can map to another character, so that it both can removed and nullify, or they both can be erased easily from the part, from that part only. So in this case, you can say I will simply check if my length of the string is odd, then I will simply print yes, or I will simply print 1. But you can see in the odd length, I can only make n by 2 pair only. But and then one pair will always be left in the n is equal to odd case. But if my n is equal to even, if my n is equal to even, then I can always make distinct pairs and remove all that pairs only. So if my maximum frequency is smaller than n by 2, I will simply check if my current length of string is odd or even and print answer in base of then. But if my maximum frequency is greater than n by 2, if my maximum frequency is greater than n by 2, then I will simply print maximum frequency minus n minus maximum frequency, which is indeed 2 into maximum frequency minus n. So this is a pretty much simple solution. So if I show its code, first of all, what I will do, I will simply count the uh, first of all, I will simply find the frequency of the character and I will find the maximum frequency. If my maximum frequency is greater than n by 2, then I will simply print 2 into maximum minus n. It is a formula you can see. If I tell you again here only, but what is a non-overlapping part here? So you can see if my this is the whole frequency of A, then I will simply minus the frequency of other characters, right? So what are the number of A left? The number of A left would be this part. So the count of this part would be my answer in that case. So you can simply print that part. But if a maximum frequency is smaller than or equal to n by 2, then I will simply print the odd or even case. If my current string is odd, then I will print yes. If my current string is even, then I will just print 0. So this is pretty much good question I can say, because I have taken too much time for solving this type of problem, but it is not a worth giving that time. So I will grade this problem as a good problem. So now let's begin to problem number D, which I was able to solve this problem in this round. So this is also good problem. So what they have said, that we will be given a position. Initially my polygraph is at position number 0. Okay, and we will be given some number of segments in that, some number of segments in the array. How are segments defined? You can see if my number of segments is 1 to 5, my number to segment is from 3 to 4. Okay, so if I tell you here only, so you can see my initial position of polygraph is 0. Okay, so I will be given some segments. So for example, this is segment number 1, this is segment number 2, this is segment number 3. But you can see this is not a possible case, which is there is no overlapping, because okay, they can also have a segment like this also. This is segment number 1, this is segment number 2. But they can also be case, if my segment number 1 is like this, my segment number 2 can be this also, can be previous to this also. But for the sake of simplicity, for understanding the question, I will tell you that initial position of polygraph is 0, and first segment like here, second is here, third is here, and fourth is here. So what they have said, I can choose a k. And what is k defined? K is defined like this. I can make a maximum jump of k. For example, the distance between this part and my 0 part is at most, for example, it is 5. The distance between 0 and this part is 5. So I can choose a k like 7. If I choose a k like 7, I can make a jump of 1, 2, 3, 4, 5, 6, and 7. I can make jump of any of these. So to move from this position to this position, I can make a jump of 5, 6, 7. I can make a jump of any of these position. I cannot make a jump of 4. Because you can see, if I make a jump of 4, I cannot reach my segment. And what they have said, in each jump, I have to move to next segment. For example, in this case, you can see my initial position 0. Then after single jump, I have to move to this position or this segment or in between this segment. Then after another jump, I have to move to this segment. Then after another jump to this segment. And after another segment to this segment. Which means after the last jump, I should be in the last segment which is given to us. Okay, so I have so you have understand problem. So how I will solve this problem? You can see this I can simply use a pretty much binary search solution in for this, because you can see they're asking us to simply finding the minimum k which will satisfy all the conditions, which will out of the minimum k I have to find the minimum k I have to find the minimum k which I can use to jump from this segment to this segment or another segment to another segment only, right? So I hope so you have understood problem. So how binary search will work? For example, if I'm taking a segment like 0 to, for example, any big number 1 in 9, so I will find a k which I am targeting now. For example, I am finding a k. So if my k is satisfying the condition, I will tell you later how I can choose how I can satisfy the condition with the given k. Let's suppose my k is satisfying the condition. If my k is satisfying the condition, which means I can choose another smaller k from this k which can satisfy the condition. For example, this k lie here. Okay, then I can decrease my search space to this part. Then I can find on this search space whether there is a k which satisfies the condition. If in this search space there isn't a single k which is satisfying a condition, then I simply print this case. But if my this k is not satisfying the condition, then I will search in a bigger search space, which means I will try to increase my k, which means I will try to increase my k or the jump which I am making. So by increasing the, I will simply check whether this k is satisfying the condition or not. But you can see how I will check whether my current k is satisfying the or not. So I think this is the only pretty much tricky part of this problem. So how to check whether a current k is satisfying the condition or not? So you see, if if I am having an initial position as 0, let's suppose I will taking like my lowest position, my current lowest position is 0, and my let me erase this part. So let's suppose my current possible lowest position is 0 and my current possible highest position is also 0, because you see my initial position of polygraph is 0 comma 0 only. So my initial smallest is 0 and my initial highest is 0 only. So what is a possible jump which I can take to reach? For example, this is a segment like this. If I want to go to segment like a of I comma first and a of I comma segment, so this is a pair in comma int only. So if I want to go from this low to this high, right? So what is a possible jump which I can make? So you can see simply if I what is the minimum possible jump which I can take. So you can see if I refer you the code, so you can see if my lowest position is like this, so how lower I can go now? I can go now lower to L minus K. Okay, so this is the current lowest position which I can go, and my current highest position which I can go is H comma K, right? Okay, you can see this is a pretty much easy, which means first I am calculating the what is the lowest position which I can go from the current position, which is low minus k, and what is the highest position which I can go from the current highest, which is high plus k. Okay, right. So but if these are the highest and lowest position, right? But where I want to go, I want to be in the range of L comma R. So let's suppose I did L comma R here only. So I want to go from L to R. So my lowest position is this, my highest position is this. So, but you can see, I cannot go lower than this, no, I cannot go higher than this. Then I will simply find the maximum of L comma L minus H. And here you can see, wait a minute, there is a confusion here. In the, so it is a L and it is AR. Then I will find the maximum of A comma L, and I will simply find the minimum minimum of, because you see my highest position at current position can be h plus k, and what is the maximum position where I can go? It is only a comma r, minimum of a comma r, because you can see I cannot go higher than a comma r, and plus h comma k. Okay, but you see, if at any point, if at any point my lower become greater than high, if my lower become greater than high, which means, if I have more visualize it to only you. So here, good. So you can see, here you can see, if my current position is like this, okay, but if my current range is like this only, okay, and my current minimum is at this position, and my current maximum at this position, but you see, if I cannot make a jump like, mm, wait a minute, like this only, if my current maximum is this and my current minimum is this, so what are the possible case where I can make a jump? So if I, for example, in the case I can make a jump like this, and for the current low I can make a jump like this, which means I can be in this range only. I can be in this range only. So I will change my minimum and maximum to this position. I will make my minimum to this and make my maximum to this part only. Okay, got it. But if you see, if my current minimum is this and my current maximum is this, right, but I can see I can go from this position to this minimum at a minimum, and at a maximum I can go from this position to, let's suppose, this position. Okay, so in this case what could be minimum position can be, you can see my minimum position can be this only. Okay, why so? But you can see if I can make a jump like this only, I can also make a jump to forward also. So in forwarding also, my minimum position lies here only, and maximum position lies here only. So if in any case my low become greater than high, then in that case my answer will never exist. Which means there is a range in which I am exceeding the test cases, or I can say there is a range in which I am not able to get my initial position. So if I tell you one more example, right? So you can see if my current position is zero, right? My current position is always zero, and my range is like this. Here it is 5, and here it is suppose 10. But if my k is only my k is only, right, suppose 2 only, and my both the position are initially zero. You know why? My both the position are initially zero. So I can make a maximum jump of k plus 2. I can go to 2 and minimum to minus 2 comma 2, right? So what are the possible position where I can go? I will simply get the maximum of L minus k comma A of L, right? So the maximum is, my maximum is 5. Okay. And what is my minimum? What is my minimum of, my minimum of 2 comma 10, right? So you can see I can make a I can make a maximum jump from 0 to this, and make a minimum jump from 0 to this, right? This case is minus k, and this case is plus k. Okay. So you can see in this case, my what is my desired position? My desired position is like that. I have to at least cross the 5 mark. But you see, I will not able to cross, because you can see my minimum part is giving me like this. My minimum position can be from minus 2 comma 5. Let's suppose I am taking like 5 only. But if you see, what is my maximum possible jump? So my maximum possible jump is 2 comma 10. And what is minimum among them? My minimum among 2 comma 10 is 2 only. So my high will be 2. So in this case you can see my low is greater than high. So in this case you can see I cannot I cannot continue further. But you see, if my, in this case only let's suppose in this case only my k is given to us like, uh, 6. Okay, so I can make a jump of 6 and make a jump of minus 6. So in this case, what is my lowest possible position? So in this case, my lowest possible position can be 5 only, because you can see my minimum of minus 6 comma 5 is 5. Okay, but you can see what is my maximum. My maximum can be minus 2 comma 6 only. I cannot decrease from here, because you can see the maximum jump from this position I can make of 6. So I cannot go further from 6. And what is my maximum range? My maximum range is 10. So I will lie from 6 to 10 only. So maximum range is 6. So you can see in this case my low is more than high, which means I can make a jump in my next segment, such that using that K I am in the another segment. So using this formula, using this approach, I will check for all the other test cases, and using the simple binary search function, I will simply print my answer. So if I show you the code, you see, first of all, I am taking the input. FF is first, SH is second, and what is a minimum jump? My minimum jump can be 0. My maximum jump can be 25. So these are like you can change this constants. So what is this function? You can see if I'm able to jump using that k, then I will decrease my search space and simply store the current answer in that. But if I cannot make a jump using that my current k, then I will simply increase my search space. I will try to make a jump with a greater k. Okay. So what is a function looking like? So this is a function. First of all, I am taking a low and high because you see initially my low is 0 and high is also 0. And you can see what is the maximum possible position of high. My maximum possible position of high is minimum of jump which he can take and the another second possible. So minimum of high comma k comma area of high comma second. And what is the minimum possible answer for the low? The minimum possible answer for the low can be low minus k comma area of first. So maximum of both low comma k and area of first. So if any of the case my low is greater than high, which means I cannot make a jump. For example, in this case we have seen if I am taking 0, if I am taking k as 2, then I can make a jump to here only. But you can say in this case my minimum low will be 5 and my maximum high will be 2 only. So in this case my low is greater than high and I will never able to make a jump. So if this is a condition, I will simply print 0, else I will simply print yes, or I can simply return 1, or I will simply print 0. So you can see based on this condition, I will simply change my variable of high and end, start and end. So I will simply print the answer in the end and return. So if you have any doubt regarding these 4 questions, you can comment me down. And please don't forget to subscribe my channel. Till then, stay tuned for the next one. Thank you.